Hundreds of people have had to leave their homes over fears over a volcanic eruption. More than 1,000 earthquakes have hit the area.
In the heart of Iceland, where the land of fire and ice meets the cosmic unknown, a harrowing tale unfolds. A state of emergency grips the serene landscapes, echoing the imminent threat of a volcanic eruption. People, with urgency etched on their faces, evacuate a small fishing town, a prelude to the unfolding disaster. The southwestern peninsula, once a tranquil expanse, now quivers under the weight of hundreds of earthquakes, each tremor a haunting reminder of the impending cataclysm. Shockwaves of seismic activity send ripples through the very fabric of Iceland, pushing experts to the edge of anticipation. As Iceland grapples with this unprecedented seismic dance, questions linger in the air. Is this merely the beginning of a cosmic spectacle? Scientists, with a mix of awe and trepidation, warn of an active volcano in the country's southwest, poised to erupt within hours. Brace yourselves as we delve into the shocking reality of a potential apocalyptic earthquake in Iceland. This is not just a geological event, it's a cosmic saga unraveling on Earth's stage. Welcome to Universal Narratives, where extraordinary tales emerge from the very fabric of the universe. Iceland, land of fire and ice, lies on the mid-Atlantic ridge, a monumental geological feature of our planet. This ridge, a dynamic boundary where the Eurasian and North American plates diverge, is not just a geographical wonder, but a dynamic boundary. This divergence is a slow but powerful process in which the plates drift apart at a rate of about 2.5 centimeters per year, roughly the same speed at which human nails grow. But what would happen if this gradual divergence suddenly accelerated? Could Iceland, this serene island of natural beauty, be on the brink of a catastrophic earthquake of apocalyptic scale? Stay with us as we explore the exact possibility of such a seismic event. At the center of Iceland's geological history is the mantle plume that lies beneath it. A mantle plume is a column of hot solid material that rises from deep within the Earth's mantle. When it reaches the crust, the heat and pressure cause the rock to melt, forming magma. This magma, less dense than the surrounding rock, rises through the crust and can lead to volcanic eruptions when it reaches the surface. The presence of this mantle plume beneath Iceland is what makes the island one of the most volcanically active places on Earth. But what does this mean for Iceland and its landscape? Consider this. When you think of a volcano, you might imagine a single conical mountain erupting lava and ash. However, in Iceland, the reality is much more complex and fascinating. The interaction between the mantle plume and the diverging tectonic plates has created a unique geological environment. This environment is characterized by a series of volcanic systems, each consisting of a central volcano and a network of fissures that extend outward. These fissures are cracks in the Earth's surface from which lava can erupt, often creating spectacular lava fields rather than traditional volcanic cones. Iceland's volcanic history is as rich as it is long. The island has been shaped and reshaped by countless eruptions over thousands of years. One of the most famous historical eruptions occurred in 1783 from the Loki Fissure system. This eruption was not only large-scale, spewing vast volumes of lava and ash, but also had profound effects far beyond Iceland. The ash cloud spread across much of the northern hemisphere, causing significant climatic anomalies and leading to crop failures and famines in Europe. It was an eruption that changed the course of history, illustrating the long-range impacts of Iceland's volcanic activity. But why should we pay attention to Iceland's volcanoes? Well, the interaction between the tectonic plates and the mantle plume beneath Iceland is not just a story of fire and brimstone. It's a story of creation and transformation. As the plates drift apart and magma rises to the surface, new land is literally formed. This process can be observed in Iceland's breathtaking landscapes, where the new volcanic rock cools and solidifies, being gradually colonized by plants and animals. It's a process of continuous renewal, where destruction is followed by creation and the land is in constant change. Yet beneath this serene process lurks a terrifying revelation. The Reykjanes Peninsula, a rugged strip of land near Iceland's capital, Reykjavik, has become the epicenter of a seismic crisis that could culminate in one of the most significant volcanic events in recent history. For weeks, the ground has been shaking incessantly, with hundreds of earthquakes rocking the region daily. But what does this mean? Are we on the brink of witnessing a volcanic spectacle of unprecedented scale? Earthquakes are often precursors of volcanic activity, acting as release valves that relieve the stress built up in the Earth's crust as magma moves and intrudes into new underground areas. It fractures the rock, causing earthquakes. This seismic activity is a crucial indicator for geologists and volcanologists who analyze the patterns and depths of these tremors to predict volcanic eruptions. But how massive might it be, you wonder? The scale of the impending eruption could be colossal. Icelandic authorities are on alert, with a state of emergency declared and nearly 4,000 people forced to flee their homes. The Icelandic Meteorological Office warns of a significant risk of eruption near Reykjavik. The ground beneath their feet is a battleground of tectonic forces, with magma accumulating just 3 miles underground. The movement of magma is usually monitored using a combination of readings of seismic activity, measurements of ground deformation, and analysis of gas emissions. Seismographs detect the tremors caused by the movement of magma, while sophisticated satellite technology also measures even the smallest changes in the Earth's surface that could indicate rising magma levels. One of the most alarming aspects of this situation is the depth and frequency of these earthquakes. The seismic activity is not just happening on the surface, but is indicative of deeper movements within the Earth's crust. This suggests that magma is moving and intruding into new underground areas, causing the rock to fracture and resulting in these earthquakes. All signs seem to indicate a significant and potentially explosive buildup of volcanic pressure, posing a serious threat both to the immediate area and surrounding regions. Due to the unpredictable nature of underground magma movements, the ground we stand on could transform into an explosive breach for volcanic fury. There has recently been a drop in the frequency of earthquakes, but instead of providing relief, this has only heightened the sense of impending doom. Dr. Margaret Hartley, a lecturer in earth sciences at the University of Manchester, warns that this could indicate a new phase of magma intrusion. In other words, the volcano is not calming down, it's gearing up for something bigger. But what could be bigger than the ongoing tremors that have already caused cracks in roads and shakes in homes? The answer is both fascinating and horrifying. An eruption at Fagradalsfjall, the likely site of volcanic activity, could unleash a torrent of lava capable of obliterating everything in its path. Dr. Phil Collins of Brunel University London paints a grim picture, suggesting significant lava flows that could destroy homes and permanently alter the landscape. But what could be bigger than the ongoing tremors that have already caused cracks in roads and shakes in homes? The question on everyone's mind is, when will the volcano erupt? But the answer is chillingly uncertain. The IMO describes the situation as teetering on a precarious balance, a magma intrusion teetering on the brink of eruption. And the situation in Grindavik, a village near the epicenter of the seismic activity, is particularly critical. In response to the growing threat, the village has undergone a complete evacuation, a clear sign of the seriousness of the situation. Imagine an entire town abandoned while the earth beneath it threatens to burst. But why is this magma movement causing so much alarm? Volcanic eruptions can vary greatly in size, duration, and type of volcanic activity. In an effusive eruption, lava flows could spread across the landscape, destroying everything in their path. This type of eruption, although less explosive, can still have devastating effects on infrastructure, such as roads, bridges, and buildings. The lava can also cover large areas of agricultural land, rendering it unusable for years to come. The 2010 eruption of Eyjafjallajökull is a glaring example. Eyjafjallajökull, a stratovolcano covered by a glacier located in southern Iceland, erupted in April 2010 after nearly 2 centuries of dormancy. The eruption was characterized by explosive activity that sent a massive ash cloud into the atmosphere. This ash cloud, composed of fine abrasive particles, posed a significant threat to aircraft, as these particles can damage jet engines and other critical aircraft systems. The scale of the air traffic disruption was unprecedented. Over an 8-day period, the ash cloud led to the closure of large portions of European airspace, grounding about 100,000 flights and affecting an estimated 10 million passengers. The economic impact was staggering, with the airline industry suffering estimated losses around 1.7 billion euros. The disruption also had a domino effect on the global economy, affecting trade, tourism, and business activities. The environmental consequences were also evident in the aftermath of the 1783 to 1784 eruption of Laki, one of the most devastating volcanic events in history. This eruption produced an incredible volume of lava, ash, and gas, with a global impact that changed the climate worldwide. In particular, the combination of sulfur dioxide and ash particles created a dry fog that covered much of Europe, causing a significant drop in temperatures and leading to extremely harsh winters. This event had a devastating impact on human populations and wildlife, causing famines, diseases, and a substantial loss of human and animal lives. But beyond the catastrophic eruptions, Iceland is also known for its quieter volcanic activity. These eruptions, often referred to as fissure eruptions, are characterized by lava flows that spread slowly across the landscape. These lava flows can last for weeks or months, creating new rock formations and transforming the landscape. So, how does Iceland prepare for a potential volcanic event? The country has a long history of managing volcanic eruptions and has developed a highly sophisticated monitoring and response system. This system relies on a network of seismic and geodetic monitoring stations, along with satellites and aircraft that monitor volcanic activity from above. These data are then analyzed by geologists and volcanologists, who use the patterns of seismic activity and ground deformation to predict volcanic eruptions. In addition, Iceland has developed emergency response plans to manage volcanic eruptions and minimize their impact on the population and environment. These plans include evacuating areas at risk, closing roads and airspaces, and distributing masks and goggles to protect people from falling ash. However, despite these efforts, volcanic eruptions remain a highly unpredictable and potentially dangerous phenomenon. So, as we continue to observe and learn from these powerful natural phenomena, the main lesson we can draw is humility. However much we may try to predict and control the forces of nature, we must ultimately accept that we are only temporary guests on this evolving planet. And in this sense, Iceland offers us a constant reminder of our position in the grand scheme of things.